Welcome to The Explainer. Today, we're going to pull back the curtain on something pretty amazing, how computers actually learn to understand our language. We're talking about turning plain old words into some really powerful data. All right, so here's our game plan. We're going to start with the absolute basics, teaching a machine grammar. Then we'll jump into some actual code to see how it works in practice. After that, we'll get into the really cool part, turning words into numbers. And we'll wrap up by seeing how machines can pick out important stuff, like names and places, from a bunch of text. Okay, so let's just dive right in. First things first, how in the world do you teach a computer the difference between a noun, a person, place, or thing, and a verb, which is an action word? You see, for us humans, this is second nature, right? We look at a phrase like, why not tell someone? And our brains just know what each word is doing. Tell is the action. Someone is the noun it's happening to. This whole process of labeling words, that's the very first step a machine has to take. And there's a fancy name for this, of course. It's called part-of-speech tagging, or just POS tagging for short. And it's not just about what a word is, it's about what it's doing in that specific sentence. This is like the absolute foundation for how machines learn to read. So if a machine is going to start slapping these labels on words, what does its dictionary even look like? Because it's not as simple as just noun or verb. It gets way more specific. Let's take a peek. Okay, check this out. This is what's so cool. A machine doesn't just see noun. It gets super granular. It uses NN for regular old noun like dog, but if it sees a proper noun, a specific name like Jinnah or a country like Pakistan, it uses NNP. That little distinction is absolutely critical for a computer to start understanding real context. And it's the same deal with verbs. The tag VB is for the basic form, right, run. But if the word is ran, the machine is smart enough to use VBD to know it happened in the past. This is how a machine starts to understand time. And as you can see, other things get tags too. Like adjectives, happy gets the tag JJ. And this just shows you how deep the rabbit hole goes. I mean, even little connecting words like and or but get their own tag, CC. Even symbols. A percentage sign gets tagged SYM. What this does is create a complete grammatical blueprint for the entire sentence. Every single piece has its place. Okay, theory is great, but let's get our hands dirty. How does this all look when we actually write some code? How do we take this idea of POS tagging and make it happen in a language like Python? So here's a snippet of Python code. What we're doing is using a super popular library for this stuff called NLTK, which stands for the Natural Language Toolkit. And really, the magic happens in that one line, post tag. We just feed our text to that function, and it does all the heavy lifting for us. It's pretty amazing. And boom, here's what we get back. The code has run, and now we have this list of pairs. You've got the original word, and right next to it, its shiny new machine-readable grammar tag. So you can see right there, the word cordially has been correctly tagged as RB, which stands for adverb. And this right here is the whole point. The computer now understands that the word monument is acting as a singular noun in this context, so it's tagged at NN. We've just successfully translated a piece of human language into a format a computer can understand. Now, tagging is a huge first step, but for a lot of the really powerful stuff in machine learning, we need to go even further. We actually need to convert our language, the words themselves, into cold, hard numbers. So how do we do that? Well, we use a concept called Ngrams. It sounds complicated, but it's really not. It's just a sequence of N items from a text. If N is 2, you get two-word phrases called Bigrams. If N is 1, you get single words, which are called Unigrams. For our example, let's keep it simple and just stick with Unigrams. All right, let's work with this tiny collection of 3 sentences. In the world of natural language processing, we call a body of text like this a corpus. Our mission, should we choose to accept it, is to turn this text into a nice, neat grid of numbers. And here it is. This is the magic. It's called a document term matrix. See how each row represents one of our sentences, and each column is a unique word from our little corpus? Now follow along. That first row is for a nice car. You see 3 ones because each of those words appears once, and the zeros mean the words good and beautiful are in that sentence. But now look at the third row. The words a and car each get a 2 because they show up twice in that sentence. Just like that, we've turned unstructured sentences into structured data that a computer can actually work with. Okay, this is getting good. We can understand grammar, and we can count words. So let's level up one more time and look at a more advanced skill, teaching a machine how to spot specific real-world things in a block of text. This is called named entity recognition, or NER for short. This is the secret sauce that lets a machine read an article and figure out that Gustave Eiffel is a person's name, Paris is a location, and Google is an organization. It's about finding the important things. And you guessed it, we're heading back to the code to see how this works. The process is going to look pretty familiar. We're still using our NLTK library, but this time we're calling a different function, NE-chunk. That stands for named entity chunking, and its whole job is to find and categorize these entities for us. And check out this output. It's this really cool tree structure. You can see it clear as day. The algorithm has grouped or chunked the words Gustave and Ethel together and labeled them as a person. This is so powerful. Imagine using this to automatically scan thousands of documents to find every mention of a specific person or company. All right, let's take a breath. In just a few minutes, we've gone from basic grammar tagging to counting words and even recognizing key names and places. So let's tie this all together. What's the big takeaway here? Look, these things we've talked about, POS tagging, turning words into numbers, NER, they're not just some abstract computer science exercises. They are the absolute bedrock of the language tech we use every single day. The chatbot you argue with, the spam filter that saves your inbox, the search engine that somehow knows exactly what you mean, it all starts right here with these fundamental building blocks. And that brings us to one last big question. We've shown how we can teach a machine the rules of language, the grammar, the structure. But can we ever teach it to truly understand meaning, the subtext, the emotion, the sarcasm? That's the next great frontier in this incredible field.